good morning students. Today we will discuss about the new chapter, so that is the modern periodic table. So this one you people already studied in 10th only. So we in first PU and second PU you people studied in detail about modern periodic table, right? So here all of you know about the modern periodic table. So here in this modern periodic table, so they have been classified into the two groups, so that are groups and the periods, right? So groups and periods. So in modern periodic table there have been 118 elements have been present. 118 elements, 118 elements have been present. So here in this modern periodic table, so the vertical columns we are called groups. Vertical columns means from top to bottom. They are called vertical columns. They are called groups. And horizontal rows from left to right. The horizontal rows we are called periods. So here in this modern periodic table, there have been the 18 groups have been present. How many groups? There have been the 18 groups have been present, and there have been the 7 periods, 7 horizontal rows. There have been the 7 horizontal rows. 18 groups and 7 periods have been present in this modern periodic table. So before doing the modern periodic table, okay, we will go for the first law. So that is, this one has been explained by the first scientist. So that is nothing but Doberanian law of triads. Law of triads. So here in this, the name is simply triads. Tri means there have been the 3 elements. There have been the 3 elements. So we will give example first. So here in this one, so that is the lithium and the sodium and the potassium. This will take 3 elements. The atomic mass of the lithium is 7. The atomic mass of sodium is 23. The atomic mass of potassium is nothing but the 39. So here in this one, so here in this case, so if we take the average of these 2 elements, if we take the average of these 2 elements, so that is nothing but the 39 plus 7, so that is nothing but the 46. If we take the average of these 2 elements, I am getting the mass of the 23, that is equal to the middle element, atomic mass of the middle element. So that one we are called the law of triads. We'll give one more example. So here it comes here the chlorine. We should take the halogens, the chlorine, the bromine, and then the iodine. The atomic mass of chlorine is nothing but the 35.5, and here this bromine is 80, and if we take the iodine, that is 127. Right. If we add these two, if we take the average of these 2 elements, that has been equal to the average mass of the middle element, that is 81 point something 25, approximately equal to the atomic mass of middle element. That one we are called the Doberanian law of triads. In this Doberanian law of triads, so the atomic mass of middle element. So this out of these triads, the middle element is bromine, right? The atomic mass of this middle element that has been equal to the average atomic mass of remaining 2 or other elements. They are called triads, right? The atomic mass of middle element is equal to the atomic mass of the other 2 elements. That one we are called the Doberanian law of the triads. We'll give one more example. So that is in terms of here the barium. That is an barium. We'll take calcium, barium, and strontium. Calcium, barium, and then strontium. The atomic mass of calcium is nothing but the 40. So here it is about the barium is 88. The strontium it is about 137. Right. So if we take the average of other 2, so that is 137 plus 40. Right. If we take the average, I am getting about 88.5, approximately equal to the average mass of middle element. So that one we are called the Doberanian law of triads. Right. So here in this law, Doberanian law is nothing but where the atomic mass of middle element, right? The atomic mass of middle element is equal to the average atomic mass of other two elements. Right. So this one we are called Lorentzian law of attracts. Here in this one, but they have some drawbacks. The main drawback is that but so this law is not applicable for higher elements. Higher elements that is not applicable. Right. So that's why we'll go more to the second law. So this law is also very good law. So that is nothing but the second law, the Newland law. Newland law of octaves. Newland law of octaves. Right. So where octaves are nothing but octave means 8. Octave means 8. Right. So we go for here in this one. So that is nothing but so the lithium. We have been arranged elements with the increasing order of the atomic mass. So after the lithium there is a beryllium. There is a boron, the carbon, nitrogen, oxygen, and then the fluorine. After the fluorine, so here we go for the sodium, right? So and then magnesium and aluminium, silicon, that is phosphorus, and then sulfur, the chlorine, and then so that is the potassium. After that there is calcium. Here in this law, so the property of these elements are arranged in the increasing mass of their atomic mass, right? So these elements are arranged in the increasing order of their atomic mass. So the properties of element get repeated after the element of 8. Means, so for example, if you consider the lithium, so 1, 2, 3, 4, 5, 6, 7 and 8 element. So that is the sodium. The property of lithium and the sodium remains the same. It will exhibit the similar property when after the 8th element. Right. So if we go for consider this one sodium 1, 2, 3, 4, 5, 6, 7 and 8. 8 is the potassium. Right. The property of the sodium and the property of potassium has been similar. The property of magnesium and the property of calcium has been similar. The property of boron and the property of the aluminum has been exhibited similar property. Right. After the 8th element. Right. 8th element so property, first property and 8th property, it will exhibit the similar physical and chemical property. So that one has been explained by so the Newland law of octaves. Octave is nothing but 8 elements. 8. Octave means 8. Right. So the property of element are arranged in the increasing order of their atomic masses. The property of element are arranged in the increasing order of their atomic masses. The property of element repeated after the 8th element. The property of element are repeated after the 8th element. Properties are nothing but whether it may be physical property, whether it may be chemical property. Understood? So, but it also has some drawbacks. Right. So the main drawback is nothing but in terms of here. So after placing the halogen, after placing the noble gas, right. So after placing the noble gas after halogen. So after halogen there should be some noble gas, right? The fluorine, after that neon, the chlorine, after that there will be an argon, right? So after placing the noble gas, after to the halogens, so this law becomes insignificant. That's the first drawback. Come for the second drawback. The second drawback is nothing but and after calcium, so this law is not hold good. After calcium, this law that will be not work. Right? Hold good, that will be not some other properties. So that is nothing but the Newland law of octaves. Right? So come for that is nothing but so the third law that is Mendeleev's periodic table. Mendeleev's periodic law. So here in this Mendeleev's periodic law, the physical and chemical properties of element or the periodic function of their atomic masses. So these elements they have been arranged according to the increasing order of their atomic masses. This one has been explained by the Mendeleev's periodic law. Right. So ಏನಂತಾರೆ Mendeleev's periodic law. So the elements are arranged in the increasing order of their atomic masses. Right. So this law has been stated that the physical and chemical properties of elements, are periodic function of their atomic masses. That is nothing but the Mendel's periodic law. Right. But they have both merits and demerits. Right. So the merits of the if we come for merits, right. So here in this merits, so these have been easy to remember, easy to study. Right. So because these elements have been arranged in the increasing order of their atomic masses, because of this arrangement, so they have been easy to study. Right. So and they have been placed in some vacant space for the elements. Right. So the future discovery, they have been placed in some empty spaces. That's the second one. Right. Come for demerits. Right. So come for demerits. Demerits so here in this demerits, so the position of hydrogen is uncertain. The position of the hydrogen is uncertain. So because whatever the hydrogen that has been placed in the first group, that will be not matched with the chemical and physical property with the first group. So that's why the position of hydrogen is uncertain. Right. So the first demerits. Come for the second demerits. If we come for second demerits, here in this one, so the lanthanides and actinides, they have been placed separately at the bottom of the periodic table. The lanthanides and actinides, they have been placed separately at the bottom of the periodic table. Right. They have been not placed inside the periodic table. They have been placed separately at the bottom of the periodic table. Right. So this one has been overcome by there's a fourth one, modern periodic table law. So that's the modern periodic table law. Modern periodic law. Modern periodic law. Right. So this one has been proposed by a scientist called Moseley. So here in this one, so the physical and chemical properties of element are periodic function of their atomic number. Right. So this one has been explained by the Moseley, proposed by Moseley. Right. So in so modern periodic law, so the physical and chemical, the properties of element are the periodic function of their atomic number. But Mendel's periodic law so atomic mass atomic number. Right. So physical and chemical properties of element are the periodic function of their atomic number. That is nothing but the modern periodic law that was proposed by the Moseley. Right. So already people have been known. So there have been in this modern periodic table, there have been how many groups? There have been 18 groups. There are 18 groups, and how many periods? There have been the 7 periods. Right. So we go for the classification of elements. Right. So these elements, we have been studying about all the 4 laws. That is Gregorian law of octets and Newland law of octaves and Mendel's periodic table and modern periodic law. Right. So we go for the classification. So these elements are classified into groups and periods. We go for the first one. So the classification of periods. Classification of periods. The classification of periods. So here in this classification of periods, the periods has been classified into 7. Right, 7 periods. So here we will discuss one by one. We will go for the first period. So here in this first period, this is very short period. So this the short period, it will be containing only 2 elements. It will be containing how many elements? Only the 2 elements. That is an hydrogen and helium. Hydrogen and helium. It will be containing only the 2 elements. Right. So here in this one, which of the orbitals are nothing but in terms scale, so that is an 1s orbital. So these 2 elements that will be involved, the 1s orbital. So for example, if you go for hydrogen atom, so the electronic configuration is 1s1, and for helium, the electron configuration is 1s2. The principal quantum number is nothing but where n equals, that is a 1, right? So this is nothing but a 1. This one we are called the principal quantum number. Whatever the number has been written, so this is the principal quantum number that can be represented by the letter n. So this one you will study about the structure of an atom. So n equals 2. So this is the very short period. It contains only the two elements. The orbitals, the involved, that is nothing but the 1s orbital. Come for the second one, the second period. Second period. So here in this second period, so the orbitals are involved, that is and 2s and 2p. These are the two orbitals are involved. Right. So these are the two orbitals are involved. So in terms of here, these elements it will be containing. So this second period containing 8 elements. This second period containing. So how many elements? There will be the 8 elements. So if we go for principal quantum number, so principal quantum numbers are nothing but in terms of here the 2. Principal quantum numbers are nothing but the 2. The maximum electron, they have been filled 8 electrons. 8 elements and 8 electrons. So 2 from in terms of here the 2s and 6 from p orbital. 8 electrons filled are the maximum. So come for the third one, the third period. Third period. The which are the orbitals are nothing but in terms of here 3s and 3p orbital. These orbitals are involved in the third period. So here in this one, so here also there will be the 8 elements. Here also it will be containing 8 elements. 8 elements iruttile. So the principal quantum number for this one is nothing but n equals 3. N equals the 3. Right. Come for the fourth period. So here in this fourth period, so there will be here it is the 4s, 3d and 4p. The orbitals has been involved here in this one, that is the 4s, 3d and 4p. Here it will be containing an 18 elements. How many elements? There have been containing 18 elements. 18 elements have been present. If I go for the principal quantum number and n equals 4. N equals the 4 element. 4. Right. So come for fifth one. Fifth period. The fifth periods are nothing but that is 5s, 4d and 5p. Right. So here also, so this fifth period is also been containing an 18 elements. Fifth period is also been containing 18 elements. The principal quantum number for this one is nothing but n equals and 5. N equals and 5. Right. So we go for the sixth period. Sixth period. Sixth period. So here in this one, so that is and 6s, 4f, 5d and 6p. So here in this one there will be the 32 elements. Here in this one there will be the 32 elements. So out of 32 elements, the 14 elements, so we have been removed, and these elements have been placed at the bottom of the periodic table. They are called lanthanides, or it is also been called inner transition elements. It is also been called inner transition elements because so these electrons they have been filled in the 4f. These electrons are filled in the 4f. So that's why they have been removed and they have been placed at the bottom of the periodic table. It starts from in terms of here, so that is in cerium to lutetium. It starts from these 14 elements. It starts from cerium and ends with the lutetium. They are called lanthanides. They are called lanthanides. So these are periods and all the group that will be studied in detail in the so upcoming the chapters. Come for the seventh period. So seventh period. So this is also here in this also period. So that is in 7s. So that is in 5f, 6d and 7p. So here this elements also will containing, this period also will containing the 32 elements. 32 elements, but 14 elements we have been removed and we have been placed at the bottom of the period table. They are called actinides. They are called the actinides. It starts from, in terms of here, the thorium and it ends with the lawrencium. It starts from thorium and ends with the lawrencium. So these have been nothing but the periods. The first period is a very short period, it will contain only 2 elements. Right. Second period it will be containing 8 elements. Right. Third period also will be containing 8 elements, and the fourth one, right? Come for the fourth one, it is 18. Fifth one is also been 18, and sixth one, that is 32, and seventh one is also been the 32. Right? Remember that one. So come for the periods. First one containing 2 periods, and next one is nothing but 8, and third one is also been 8. And fourth one and fifth one, there have been 18, and next is 6th and 7th, 32. Right. So come for the groups. Right. So if we come for the groups, here in this one group, so the group 1 elements. So we have been called the group. So for example, if we go for here, that is the group 1 lithium and the sodium, the potassium, rubidium, cesium, and then the francium. This is called the first group elements. This is called the first group elements. So these first group elements we are called alkali metals. The first group elements we are called alkali metals. And the second group elements we are called an alkali earth metals. The second group elements we are called alkali earth metal. So these exhibiting the group means it will be exhibit the same physical and chemical property. Same physical and chemical property. The group 2 elements we are called alkali earth metals. And the group 16 elements. The group 16 elements we are called chalcogens. Group 16 elements we are called chalcogens. Right. So the group 17 elements we are called halogens. Group 17 elements we are called halogens. And the group 18 elements we are called noble gas. Group 18 elements we are called the noble gas. Right. The group 1 elements we are called an alkali metal. Right. So alkali metals. Alkali metal group elements are called alkali earth metals. Alkali earth metals. Right. Remember that the group elements we are group 1 elements we are called alkali metal. Group 2 elements we are called alkali earth metal. Group 16 elements we are called chalcogens. Why we are being called chalcogens means in terms of the group 16 element that belongs to oxygen family. Oxygen family, they will form oxide with respect to elements. For example, ferrous oxide, right? Cuprous oxide, zinc oxide. So this in terms of it will be has complex forming capacity. That's why they are called chalcogens.